10.2, we started last time looking at displaying data, and we got about halfway through. We're going to pick up on example number 6 and take a look at a visual way to display basically the same information that we did when we created our group frequency table. So if you remember on our group frequency table, we lose a little bit of the uniqueness of our data by creating these groups that creates these broad categories. So we no longer know if it was a 99 or a 90 that someone got. They just got in that range of values. So we lose a little bit. But what we're going to do is we're going to actually create essentially a bar graph, but it's called a histogram. There's a unique difference we'll talk about. And they're adjoining rectangles or bars. The categories are shown along the horizontal axis, so like your x-axis. And the frequency is along the vertical axis or the y-axis. So our example that we're going to use is actually the same example we ended with last time, for which we created this group frequency table. So this is the table that you want to reference as you're creating the next graph. So here's our same data set, and it talked about a horizontal and a vertical axis, and we're really going to be just above and to the right of that. So we don't need to have an XY axis that shows negative values. That's not going to be part of this graph. Our frequency is along the vertical axis, and the frequency needs to make sure it kind of matches what we have over here. Our frequency on this went from a smallest value of 2 to the largest value of 9. So as we're doing this, we can do individual tally marks and it makes sense. If we had frequency values that were considerably larger, it might make sense to do our frequency like hash marks like in 5s or every other like in odds or evens, or not odds, evens or 10s or something like that. But for this one, our data values are small enough that it makes good sense, not our data values, but our frequency values, to just do hash marks for 1s. Even if you make each hash mark worth 1, that doesn't mean you have to label every single one of them, but you should label, enough of them that we can see it and not have to keep, counting or guessing where we are. So I'm going to label every other value. And even though I don't have a 10, I'll put a 10 on there just for the labeling purposes. If you want to label them all, you can, but sometimes when we get to writing too small, it just actually looks messier when we do. And we need to make sure we put labels as we're doing our axes. So this label will always be frequency in a histogram. And then we're going to do our lower axis. So our lower axis our horizontal axis needs to represent the grade categories. So it's going to go from 60 to 70 to 80 to 90. And in a histogram, our bars actually touch one another. So this actually goes from 60 to 70 like this, and we're just going to make a hash mark at every 10 place value. And it will look very much like a grade distribution when you do that. All right, so our first distribution, our first category rather, says that we have 3 scores in the 60s range. So we're going to create a bar that is 3 high, like this. And then in our 70s range, we have 2 values, so we need a bar that is at a height of 2 for the frequency. The 80s range has 4 values in it, so we want a height of 4 in our 80s range of values. And then the last one in the 90s range of values, we have 9. So it needs to be a really tall bar comparative to the others, and we'll be up here at 9. Pardon me if it's not perfect. It's sometimes scaling issues that are playing with my mind. If you want to use grid paper, like graph paper kind of stuff, when you're drawing something like this, you're welcome to do that. If you don't want to buy graph paper, you can print it online as well. So that's another option, and just use some kind of an alternating color. something darker than the grid paper. The grid paper sometimes ends up being kind of dark itself, so you might have to actually use something that's not black or pencil to do it with. We need to label the axis on the bottom. So these are the grades. And then our entire picture needs a title, just like the rest of them that we've done. So these are actually grades on or from a second exam. And it's called a histogram. The reason a histogram makes sense with this data is because we've created categories for the data where we've lost the accuracy of the values. And so we don't have, like if you're imagining plotting an XY ordered pair for each data value, that's not what this graph does, right? It collects all the data and it puts them in these categories. And for grades, this makes a lot of sense. These categories are on a continuum, right? A 69 to a 70, this sort of makes sense that they're like beside each other in terms of values. And so the bars touching makes a lot of sense in this way. There is a type of graph that's the next one, though, that is actually a bar graph. It's quite similar to a histogram. It looks very much the same, but they have spaces between the bars. And they're typically depicting categorical data, as in data that we not necessarily assign along a numerical sort of grid, kind of like we did the last one, like, at 60, 70, 80, it's all this numerical sort of fluid values, but they're isolated different things. So we're going to do one that's still the same data set, but a lot of times you see categorical data if you were to compare like freshman, sophomore, junior, senior, and it's the number of people, that, I don't know, took a certain class or that got a certain grade or that have a certain GPA or that come from, those kinds of things. So you're comparing, right, freshman, sophomore, junior, senior doesn't make sense for them to be next to each other. It's not a continuum anymore. They're categories of data. Or if you were doing something that was like male, female, there are these categories of data. It's not on a continuum, and so it doesn't make sense like numerical values being on a continuum would. So grades are interesting because you can talk about grades being on a continuum like this, right? But you can also talk about grades being in categories, as in the letter grade itself. So our next graph, although it looks a lot like the one we just did, is going to have grade categories where on the bottom, instead of listing data values, right, the 60, 70, and 80, it's going to list letter grades, A, B, C, D. Okay? So we're going to draw the same grid we had before. It will have the same axes. It'll say the same things like frequency and grades. All that stuff will be the same. I'm still going to label every other just for it to be less kind of muddled up. So that axis doesn't look any different. This bottom axis will be called grades, but it will look slightly different. Instead of having bars that touch, our bars, this is going to be my bar representing the letter grade of D, is going to be separated from the next bar, which is going to be a C. And it'll be separated from the next one, which is a B, and separated from my next one, which is an A. So those little hash marks aren't really hash marks. They're just going to mark the edges of my bars. So when I draw my bar that's representing the letter grade of D, and there were 3 of them, those 2 hash marks that I made before are really just the front end and the back end of the width of my bar. And for my C, same thing. I have the 2 front and back end of my bar. I'm going to have a 4 in the front and back end, and you've got these little separating pieces in between, and then we have a 9. A few things about the bars, and this is true for bars on both of these graphs. The bars should be roughly the same width, right? So you shouldn't make one tall and like super skinny and one fat. That gives the illusion of something that's not true. So they should be the same width, and they should be spaced roughly apart equally, right? So if I made these spaces different, which would force the bars to be different, the image would sort of be skewed. It would look like what we're not trying to display in an accurate way. Same thing for these. So we don't want like big gaping holes between my bars. In fact, my bar for A is a little bit further apart than I would really prefer it to be. I'd prefer it to be a little bit closer, but you have the right idea. I'm not super nitpicky about it, but sometimes it's really obvious that you have not taken great care or any care in drawing things. So take some care in drawing it, make sure it looks reasonable. We do still need a title. Title is the same thing we've been using on this one before. This is grades from a second exam. Okay, so the next one is actually a kind of a combination graph. Do you remember the only graph we've had so far that is able to be used for comparison? Do you remember what it was? Where it compares two sets of data? The back-to-back stem and leaf plot. Yeah, so the back-to-back stem and leaf plot, I'll flip one over to one of them. Oh, there it was. It was right here. It's on the right-hand side. And we had the second exam on the right. We had the first exam extending over here to the left. And it is a stem and leaf plot, but since it has two sets of data on it, it allows us to sort of make a visual comparison of data. Our bar graph that we're about to do is called a double bar graph, and it does the same thing. It allows for us to make comparisons in data. So there's going to be data both from the one we've been doing that I've done the histogram and the bar graph for, and from the first exam that we haven't actually created such a display of data from already before, a way that we're going to make these comparisons. So it might be helpful for us to go back over here and to take a look at our back-to-back stem and leaf plot and count some things up. Now, I don't really need to know the right-hand side. I've already got a frequency table. I've already done two bar graphs, the histogram and the bar graph, that both have that data. It's really the part on the left that I'm most concerned about with. For example, if I'm looking at A's on this one, I notice there's 4 A's. Right, I'm going to need that. If I'm looking at B's, I see that there's 6 B's. And if I'm looking at C's, there's 4 C's. There's 1 D, and then there's 3 F's. So that's actually the information that I'm going to need. I'm going to copy this to my other screen so that we will have it, just that part of it. Actually, I'm going to put it right here, and then we'll be able to flip back and forth easily. So this was my stem and leaf plot, and when I looked at my data, I'm saying that there's 4 90s, there's 8 80s, there's 4 70s, there's 1 61D, and then these two kind of end up getting grouped together because they're all Fs, and that's 3 Fs. Okay, pretty good with that? And then the group frequency table over here that I had, I'll move it over as well so it's easy for us to see alongside. Had those same pieces identified. That's my second data set, 3, 2, 4, 9. Notice it doesn't have any Fs listed, so Fs would just be 0, right, on the second exam one. That would. All right, so as I'm creating a bar graph, we're going to create the vertical piece just like we have been doing. It's going to be frequency. So I'm going to mark off 0 to 9, or 10, that's what I've been doing. And this is frequency. On the bottom, we're doing letter grades. It's a bar graph. Okay, so it's still categorical data. So I will actually have a category for Fs, and then it'll split, and I'll have a category for Ds, and then a category for Cs. So this is, I'll go back and label them, and no, I'll label them now. So here's my Fs, Ds, Cs. Let's skip a little space. This is my B's, and then my A's. Oops, A's. And these are grades. And my bars are going to actually be half the width that I have allotted for each space. So, for example, on the first test, there were 3 F's, but on the second test, there were 0. So on the first test, if you want to sort of think about me subdividing the F category, I'm going to have 3 F's represented at a vertical bar in that. That's not very good. Let's try it again. But there won't be a vertical bar on the other half of the F piece because there simply weren't any F's. On the first test, there were actually only 1 D, I think was right. Is that true? Let's see, what do I have? Yeah, 1 D. And on the second test, there's 3 Ds. So on the first test, 1 D means on the D category range that I've now split, I'm going to have a bar of height 1, because there was 1 D. But on the second half of the D range, I'm going to have a bar of height 3, because there were 3 Ds on the second test. So there's 2 bars representing D, 1 for the first test, 1 for the second test, and we just go in order. C's, there are 4 C's on the first test, and there are 2 C's on the second test. So 4 and 2 is my heights. I'm going to split my C category. I have a height of 4, and I have a height of 2. So that's approximately 4, and here's about 2. In my B range, I have 8 on test 1 and 4 on test 2. So we'll split the B up, and we'll do 8 and 4.
You said 8 on this one?
Yeah, there were 8 on test 1, and then there's 4 on test 2. And then my A range, there's 4 on test 1 and 9 on test 2. So 4 and 9 after I split up the A. So here's 4, and then we're going to have the other one at 9. Okay. Okay, now if you just left all your bars like this is a confusing looking picture. Agreed? I mean, how do you you have to really think hard and really look carefully to make sure you're looking at test 1 or test 2. So there's a couple of things that you can do. If you have something to shade with color-wise, you're welcome to use crayons, markers, pencils, things like that to color things differently. So I'm going to do that. I'm going to show you what you can do if you don't have that in a moment. So if you don't have anything colored-wise, just hold tight. So on a test 1, I'm going to shade everything in yellow for test 1. And I'm going to shade everything in, let's go with green for test 2. So I have green here, and here, and here. And here. And then I have to tell the reader, of the graph, basically what those colors mean. So over here, I'm going to create a little key that's going to show my colors, whatever they were, green and yellow. And I'm going to label that this is exam 1, and this one is exam 2. If you were working and you didn't have any colors and you didn't want to go find one because, you're just somewhere where it just doesn't make sense and you're trying to, get this thing taken care of, another thing that you can do is you can shade your pictures in a different way. For example, let's say you just have your pencil, and so you shade everything that's yellow sort of going from left to right, at a diagonal like this.
What if you were
You could possibly do that. It still ends up looking a little incomplete when you do that. So what might be a better choice is to shade in a different direction. So since I'm shading from sort of bottom left to top right, you could shade the opposite way. So you could do something like this to differentiate, or you could simply make your shading more distinct, like it's horizontal or vertical instead of side to side. So whatever you do, you're just shading it differently, and your key would just match whatever you've done. I do have markers in this classroom, so as you're taking a test or if you're doing your group work or whatever and you just want to borrow some, we can definitely get the markers out. That's not a problem. So whatever you choose to do with that. But the picture would look something like that without the colors in them if you did shading. And then we still need a title. So our title is going to say that these are the first and second exam scores. Where this key holds. So if you've written your key next to it, or you don't necessarily have to use the word where, but the key actually has to be present for sure. Okay, so we're not going to draw the pie charts today because I want to show you how to use the protractor to draw them, but we're going to do all the setup before we draw them because the setup itself is actually where all the work is. So let's take a look at our last graph in this section. This is a circle graph or a pie chart. It consists of a circular region partitioned into disjoint segments, right? So like think about pieces of a pizza. This graph shows how parts are related to a whole. Now that's something that's actually really important. Everything that we've done so far, if anytime we've compared something, has been comparison of parts to parts, right? It's like, how does exam 1 relate to exam 2? Not how does exam 1 relate to, or how does a certain score on exam 1 relate to a certain, the whole score, sets of scores on exam 1. Right? It's not like that. It's not like we're comparing one person to the whole. We're actually trying to compare the pieces instead. This one is a comparison to the whole. And so what we do is we take our values and we figure out what proportion of the whole do we have. So this actually extends back to some of the things that we did with proportions back in chapter 6 and chapter 7. We saw proportions in both of those places. Chapter 6 was our first encounter with them. So it goes all the way back to chapter 6. So we're going to use our same data set that we had right here as our reference point. And I'm going to copy it over here so that we can use this here. And to collapse things a little bit, I'm going to take out the tally column because I don't really need it. And we're just going to move the frequency over. Okay, so we've got our grades, we've got our frequency. Both of those pieces of information are necessary to make what we're doing work. I really care about the letter grades, so I'm going to go ahead and write those in, D, C, B, and F. And we don't really care so much about the numerical value of the grade span, but those are our values. All right, so how many total tests is this? That's the first thing we need to know, or we won't be able to proceed. So how many people took this test? What's wrong? Oh, I wrote F. I didn't mean write F. Thank you. It should be an A. I definitely want those A's to be B's. Thanks. Okay, back to my question. How many people took the test? 18. How'd you get 18, Braden?
I did 3 and 2, 5, and then plus 4, and then
Yeah.
9.
So we're just adding up the frequencies, right? Yeah, those frequencies represent the test takers. We're adding them together to find out how many people took the test, 18. What we want to know is we want to know what percentage of each of these, values accounts for the whole. So in other words, I have 3 D's out of 18. what is that? How much is that of the whole? And I needed to represent it in two different ways. So for right now, actually, let me leave this as 318 in this column because we'll come back to it in a moment. And we're going to take the next column and we're going to make the next column. This will be like a column representing the fraction. And this will be the column representing the percent. And you'll see why I want that fraction later to be used in a different way. So 318 for my fraction. How many, or what would my fraction be for my C's? Yeah, 2 out of 18. What would it be for my B's? 4 out of 18. And what would it be for my A's? 9 out of 18. Okay, are those fractions okay? All right, so we've talked before about ways that we turn fractions into percents. We're going to take that fractional value and we're going to turn it into a decimal. We're going to do the division. Our calculators are just fine to do so, and we're going to multiply by 100. So in essence, we're going to take, this is a little too close now. There. We're going to take that 3 out of 18, divide in our calculator, and multiply by 100. So what is 3 out of 18 times 100? And we'll use whole percentages because it's accurate enough, really. Okay? So grab your calculator. 3 divided by 18 times 100. What do you get? So it's 16.6, isn't it? Like 6 repeating?
That was after I multiplied by 100. That's the answer I got. Yeah, it's 16.6 repeating.
Okay, yeah, so I think the answer's coming up like this.
Yes.
Right, and the sixes keep going. So we'll round to 17. We're going to use just our regular rounding rules. So we'll go with 17. Okay, is that all right with everybody?
Can you use it like zoom in on what you're, or make it bigger?
Yeah, hang on, let me try.
Should we be writing this all down, or is this just?
Well, at the very least, you need the percentage written down.
Okay.
Because we're going to, and then that 3 over 18, we're going to have to the side. So do you have to write my formula that I wrote? No. I mean, if you just know what I'm doing, that's fine too. That won't hurt anything. It's 17%. Is that okay, Abby? Size-wise better? Okay, good. We have 2 divided by 18 now times 100. What is it? 11%. And then we've got 4 over 18 times 100. Should be about double what we just got, right? Is it 22? Good. Sometimes it doesn't work exactly right when we are doing a little bit of rounding along the way. 9 divided by 18 times 100 is fantastic. What does it give you? Yeah, that's 50. Okay, so you need to know the percentages. You absolutely need to know the percentages. So those are our 4 percentages. We're going to need to know those. The other thing that we're going to need to know is we're going to need to know what percentage of a circle this represents. And not necessarily percentage. We know what percentage. It's 11% or it's 16% or 17% or whatever. But we need to know the degree measure that corresponds to. So instead of multiplying by 100 in our last column, we're going to take those same fractions, right? 3 over 18, 2 over 18, and so forth. And we're going to multiply by 360 degrees. Because that's the value of the degrees in a circle, right? 360 degrees. So I don't really want you to go back and say, oh, I'm going to use 0.17 because we approximated that, right? We rounded, so we'll use the 3 over 18 exactly because it may actually not need to be rounded, and our rounded version would actually be less accurate. So what is 3 over 18 times 360? Yeah, it's 60 degrees. So this column represents the degree in the circle. This one represents the percent, and then we had the fraction as our previous one. So yeah, it's 60 degrees. And then we're going to have 2 over 18 times 360. What will that be? 40 degrees. We're going to have, let's see what we had, 4 over 18 times 360. Hoping it's 80. Is it?
80, yeah.
It's okay, good. And then we have 9 over 18 times 360, which should be half the circle, or 180. So the most important pieces that are going to actually be taken from this chart and put into my circle graph are these values that are the degrees, these values that are the percents, and these values that are the letter grades. Those are the pieces we need. So as we draw this, the first sort of bit of advice that I have is to take something that's circular, and some of you have things sitting on your desk, like water bottles and pop cans and things like that. So I have an unfair advantage because I have a circle tool. It's totally unfair. But we're going to draw a circle as much as we can make it perfect-ish to start with. Yeah. Borrow a bottle from somebody nearby, and if it's anything like mine, it might be dinged up on the bottom. I apologize if that's one you've got. It'll be okay. I promise it'll be okay. Okay, so what I'm going to do first today is I'm going to approximate what the picture looks like, and then when we come back next time, I'm going to actually hand out protractors. I'll go find them, and they're somewhere over there in mine or Dr. Marsh's office. We're going to find the protractors, and I'm going to show you how you actually draw it in with the protractors. But I'm at least going to show you how the picture gets labeled and everything today because we have the time to do that. So we're going to approximate the center and put a dot there of your circle. When we come back next time, what you'll actually do is there's a specific dot, basically, where it looks like something crosses on your protractor that you'll line up at that dot along one of these sides. So you're going to draw a radius out to the side of the circle. It doesn't matter whether you draw it where I drew it or if you draw it straight over here or if you draw it up here. I don't care. Just draw yourself a radius somewhere, okay? And this is your reference point, the dot in the center and this straight radius that you've drawn to the edge. That's what you're going to be using. In particular, there's a few things that you need to make sure of. You need to make sure that things go sort of in order, like we don't go from A to C on the circle graph, right? Like that doesn't make any sense. It would go in order, A's to B's to C's to D's, or backwards if you prefer D down to A. But they go in order as you go around the circle. It's often easiest to start with the biggest percentage, in this case especially because it's exactly half. That actually draws very nicely into your circle because you can actually draw your diameter across like that, wherever it is you wish it to be. And your A's, in this case, you can put them on top or put them on the bottom, it doesn't matter, are in 1/2 of this picture. And inside the A range, you write the percentage. If you really want to write the degree measure, you can. But the degree measure is already visible by the size of the shape, so it's not necessary. However, the percentage is necessary. So you write the percent in and you write the letter grade in, or whatever the category is that you're working with. So we'll talk on specifics on how to get the rest of them next time, but let me show you approximately what it would look like if we did this today. So the next one after A would be the B's, and the B says that it should be 80 degrees. 90 degrees, you know what that looks like, right? You've got an image in your mind. It looks something like this if I were to draw a 90-degree mark. So mine needs to be a little bit less. So I'm just visualizing it right now. We'll do it for reals next time and measure 80, but it would look something like that. And this would be the B range, and inside of that area we would write the percentage that B is, which is 22%.
Just a round on our homework as well.
On your percents, yeah, just use a whole number rounding. They may or may not round to 1 decimal place on some examples or something like that, but if you're creating one yourself, whole numbers are just fine. We'll be good with that. The caveat to that is recognize that while these should all add up to 100, if we've rounded things, they might not. They might add up to 99 or to 101. It'll be okay. It's fine. Okay. Our C is next. Our C is supposed to be 40 degrees and represent 11%. So again, I'm kind of eyeballing as we go, but it would look something like that maybe. We'll do it for reals next time, but this would be my C, and it would represent 11%. And then the last one, we will check it with the protractor when we get to it. We won't actually draw it because it's the only thing left. This should represent the remaining 60 degrees that we're supposed to be at, and 17%. Okay, so I have no doubt that my graph is not accurate. We'll get the accuracy component down next time. But we do need one more thing before we stop our picture. A title, yes we do. And it's the same title that we've come to know and love. This is Grades on a Second Exam. So next time, here's what we will do. We will come back. We will finish this example with the protractors. I probably will not record that because it won't make sense. I can't draw it on the screen anyway. Like I'm going to actually give you a protractor and you're going to do it by hand. So we'll finish that first. We will start 10.3, get maybe about a third of the way in or something like that. And then we'll stop for group work, which means this assignment will be due Monday.